We're now ready to see the solution to our polymorphism problem, and it's really quite a simple one. To have the compiler be able to determine which function to call at runtime based not on the data type of the variable, but of the type of object that's actually stored in the variable, such as right here, where we have imp pointer pointing to a manager object, we need to make the function in question in the base class a virtual function. And by virtual, I'm saying it's polymorphic, like so, by typing the keyword virtual before the return data type. And what this means is that now the compiler will look at that function, know that it's virtual, and determine which code to run based on the type of object that is stored in the variable rather than just the data type that the variable was declared as. Now, it's necessary, absolutely necessary, that you make the base class function a virtual function. It's not required, but it's recommended that you also make the derived class function virtual also. That will just make your intent easier to read for someone looking at your code. So now that we've made gross pay virtual in both the base class and the derived class, we can build and run our program, and you'll see that now we're getting the correct answer. Jones gets paid $1,000, that's 25 times 40 hours, and Smith, who is a manager, gets paid the salary of $1,200, which is what they are supposed to get paid based on the fact that their salaried field is set to true. By marking a function as virtual, we were able to let the compiler decide at runtime, or dynamically, which function to execute based on the type of object that it's working with. We can now also go back and fix our vector problem so that the vector objects will also be called correctly. First, let's make sure we have the vector class pound included, and we do. So let's come back down to our code. We'll create a vector object. Now this time it needs to be a employee pointer vector. Again, because we need pointers for the compiler to work correctly. And then we can push back our two objects, and they need to be references. So imp1, there we go, and manager1. And then we can write a loop. This is going to look a little funny. And then we'll end the line right below it. And then we can do the pay the same way. Employee sub I, and then a pointer to gross pay, and we'll just pass in 40 hours. And then end line. And then close the loop. Make sure our code looks correct. And it does. And now let's build and run. And so the second set of names and pay are coming from the vector, and you'll see that it is still finding the right function to call based on the type of object that it comes across. So now you see the advantages of polymorphism. By making our functions polymorphic, we can store objects of any type, be it of the base class or the derived class, in a single container, and then call the correct function for that object based on the type of object that it is. And that makes our programs much more flexible, especially when we're dealing with objects of related classes. So that wraps up this lesson on virtual functions, and now we're ready to look at one more idea behind polymorphism, and that's the idea of the abstract class. An abstract class is a class that has function declarations, but not executable code in them. For example, I can have a shape class that has a virtual function draw, but then is only implemented with specific types of shapes, such as the draw function for a circle or the draw function for a square. And we're going to see how to create abstract classes in the next lesson.